Okay, guys, listen up. Today, in this whole section, the section today, we're going to be working on distance, rate, and time problems, or it has rate, time, distance problems up there. This is critical that you know this. Distance equals rate times time, or better yet, rather than having it written out so much, D equals RT, right? R next to T means time. Now, there are a couple of things that we've got to get into our head here that help us solve these problems. And that is, when objects are traveling toward each other, they cover a total distance. So we add their distances together to equal the total. Okay? When objects are traveling toward each other. So if Alfredo and Edward were walking toward each other, their distance, Edward's distance that he covers, plus Alfredo's distance would equal the total distance. Do you agree? Okay. That's similar to this problem that we're looking at. You're going to see that it says bicyclists Brent and Jane started at noon. Okay, they started at noon from points 60 kilometers apart. Okay, so here's Brent over here, and here's Jane, and they're 60 kilometers apart. Here, I'll write Jane a little larger there. 60 kilometers. Now, they ride toward each other. So that means if I add Brent's distance to Jane's distance, what should I get? What should I get, Jack? No, not 30. They didn't go half. One may be going faster than the other. If I add their distances together, what do we get, Tara? 60, the whole distance between them, right? Because they're going toward each other. All right. Now it says that Brent's speed is 4 kilometers greater than Jane's speed. Find their speeds. Now here's how we do it. I know that Brent's distance, I'll put a big D with a little b down here meaning Brent's distance, plus Jane's distance is equal to 60 kilometers. Do you agree with that?
Yes.
Okay, D stands for distance. Distance of Brent plus distance of Jane. But what does D equal again?
Distance.
Yeah, it stands for distance, but
60 kilometers.
D equals what, Ben? RT, rate times time. Now, let's say that Jane's distance, her rate times time is, well, what's the time? I'm sorry. No, they start at 12, but they ride until 1:30. So what's the time? Okay, or 1.5? Can we say that? Okay. So I'm going to say that Jane's rate is 1.5 times R, or her distance, I'm sorry. Do you see that that's R times T? 1.5 times R? T is 1.5, right? Okay. How can I represent Brent's distance? His rate times time. What is his rate? What is his rate, Eric?
J plus 4.
R plus 4, right? It's Jane's rate plus 4. Okay. So he's R plus 4. And what's his time? How long does he travel? Well, how long does he travel, Ben? 1.5, because that's when they met, right? All right, so 1.5. When I add those two things together, I need to get 60. Because remember, Brent's distance is rate times time, and Jane's distance is rate times time. So I can do rate times time plus rate times time, because that's what distance equals, each of their distances. So let's solve this thing. I'm going to get 1.5 R plus 6 plus 1.5 R is equal to 60. Okay, I need to combine like terms, and I'm going to get 3R plus 6 is equal to 60. I'm going to subtract 6 from both sides, and I'm going to get 3R is equal to 54. Then I'm going to divide by 3 on both sides, and R is equal to 18. Now, what did R stand for?
Rate.
Whose rate? Jane's rate. Okay, so this is for Jane. What's Brent's rate? Eric?
22.
Brent's 22 because he's 4 more. 22 what? Cows? Trees? Kilometers per hour.